Hey class, here we are in the first of our mini videos for this summer. I'm going to try to do one video per activity and go over a few main concepts and a few main ideas, and I'm going to post these to YouTube, which in turn will then be posted to Google Classroom, so you can look at it, get help, comment on Google Classroom for other questions you have, all that good stuff. So anyways, we're going to start with the first activity, which is pretty simple. It's called Analyzing Mean, Median, Mode, and Range. So quick little review from 6th grade, what these things mean. No pun intended there. What the mean is essentially the average. You add them up and divide by how many there are. So, 6. Just a quick little example I'm coming up with off the top of my head here. Divided by 4 because there's 4 numbers, and that would be 17 over 4. I did my math right. All right, so you know what mean is. Mean is average, that's what that means, okay? The median, which we will actually be doing a ton of stuff with the median this school year, is the number in the middle. Okay, so if our data set is something like 2, 4, 5, 5, 7, and 10, the median in this case is actually 2 numbers, 5 and 5. So obviously the median is going to be 5 because you add up those two and divide by 2. 5 plus 5 is 10 divided by 2 would be 5. Okay. So yeah, median is also very important. We'll talk about the differences of those in the first few weeks of the school year coming up in a few weeks, and that'll kind of help you to kind of know what's going on there. So the next one is mode. Is that right? Yeah, mode. This is the number that appears the most. And we'll talk about that a little bit. There was a question on last year's AP exam that had to do with the mode. To be honest, that could have been one of the little small things that could have been those 2s that I texted you about that could have been 3s. I don't know. I feel like the people I'm thinking of actually got that one right after I spoke with them. So maybe not. But anyways, every little bit helps. Like I said, 6 out of the 13 passed. I really think 2 or 3 of the 2s were extremely close to being 3s, and that's all we're really aiming for. 4s and 5s are great, but 3s get you the same college credit. So 3s are just as good as a 4, just as good as a 5. Anyway, so yeah, mode appears the most. Sorry, I was rambling on there. And then the range is the maximum minus the minimum. And you would use the range just to know what the data spans. Does it span from 1 to 100? Does it span from 0 to 5? Does it span from 17 to 846,022? I don't know, whatever. Okay? So those are what those 4 things mean. And there's a lot of those questions in this activity that kind of deal with that. So let's look at number 1. Okay? Number 1 says a student has 6 test grades in algebra. Her average is the median of her test grades. Create a data set that is favorable to the student, and then create a set of data that is unfavorable. Okay? So here would be one that's favorable. Her average is the median of her test grades. So let's say favorable would be something like this. What if she made 98, 99? There's 6 test scores. That's 5. Okay, this would be favorable because her average would be a 99.5, right? That's really good. Everything's good there. That's a good grade. So that would be a data set that's favorable to her because the 2 middle numbers fall at a high point. Another example would be, honestly, you could do this. 88. What if she made 88s on the top 6 and then made 0s on the other? Those 0s do not affect her grade at all, okay? Because the median is the middle 2 added up, and 88 plus 88 divided by 2 would be 88. So even though she failed or didn't take these 2 tests, she still made an 88. It would be the same as if she made 85s on these 2 tests. The median would still be the same. Okay, so those 2 data sets are examples of things that are favorable to her. These 0s do not affect her grade. Okay, so then unfavorable is really just going to kind of flip-flop things a little bit. Okay, what if she made this? She made a 65. Well, she made 65s on the first two, and then made 100s on the last two, or 65 on the first four, and then 100s on the last two. All right, well, her average is going to be a 65. Even though she made two 100s, those two 100s are not affecting her grade at all. She could have made 65s on those last two tests, and she would still have a 65 in class. So that's very unfavorable to her. Okay, so that just kind of goes with showing how median is the middle number. That means the things that happen on the left-hand side and the right-hand side of the median do not affect the median in any way. Now, if you're talking about mean, where you were adding these up and dividing by 6, of course, then both of these would be different, which is what you're looking at kind of in 2 and 3. Okay, so that's kind of the same idea of what you're looking at moving forward there. Let's skip on down to number 4. 2 and 3, again, are very similar. And the only things we're really going to look at on number 4 is question C. Some of y'all had some questions about, like, are you looking for a math answer here or just a common sense answer? And if there's such thing as a common sense answer, then yes, common sense is always good. Or logic, I think, is what Olivia said. Maybe not common sense. It's not, common sense. It does take a little bit of skill there. So, 4C, it gives you a set of different houses and the median resale price of a house in the year 2002, and I want you to pick which city you would live in. You can make arguments on all of these. Let's say we chose San Francisco. Why might someone choose San Francisco as a good place to live if the median resale price was $571,000? Holy cow, guys. I couldn't afford to live in California. I'd be living in a box or in a van down by the river. 571, oh, there's a text message. It's an image of some sort. I wonder what it is. We'll see later. So $571,000 would be great if you are selling a house. So that would be kind of your logic behind why San Francisco would be a good place to live, because then you could sell your house for that much money, move to San Antonio and buy 3 houses. Okay? So clearly that wouldn't make much sense. But there's logic answers there on why different houses would be better for different places. It also brings into fact the income. So San Francisco, again, that would be the only reason why you might want to do that. I would, if you factor in the income, I would probably say Dallas. The income is closest to the house price. Okay? So if you're factoring in income, I didn't see that looking at it at first. Factoring in income, then Dallas is probably going to be your good one. Because you can take the income in Dallas and multiply it by like 4 or 5, and you can pay for a house. If you go to San Francisco and you do 40,000 times 5, you're nowhere close to paying for that $571,000 house. Okay, San Antonio, a little bit closer, but still, Dallas, it's more equitable, the income to house price ratio. So both of those are really good just at determining the scenario you're in. So that's where that state reasons for your selection based on the data would come in. Dallas, though, is going to be the best choice when you're factoring in both numbers. And that's kind of the things that AP is going to be looking for. They're looking for you taking the whole picture and factoring everything in. D, what generalizations can you make from this data? It's expensive to live in California, number 1. Do you think they're always true? No. Of course, you could find a house in California that's very affordable. Or you might find a condo or an apartment or something like that. Same thing in Texas. Okay, you might say, oh, well, it's more equitable to live in Texas. Well, Dallas is a really big city, and there's some suburbs in Dallas that, yes, it's a very economical place to live, and there's also some places in Texas where your houses cost extremely a lot of money. I mean, y'all have seen Fixer Upper, and y'all have seen Waco, which is not that far from Dallas. Some of the houses that they fix up in that show are way above the median income. If you want to be in certain neighborhoods, you have to pay more. So that's kind of your catch there on part D. All right, So just those are really just logical answers. Like if you were really in that situation, trying to decide which um, city you wanted to move to for your job, and those were your incomes, and those with the house prices cost, I would choose Dallas because you can afford to buy a house there, whereas San Francisco you can't, even though you're making $8,000 more a year, making $40,357. It's not as feasible to live off of. Okay, let's look at the last page here. Actually, this is a pretty short activity. Shouldn't have taken y'all long to complete that. And I really like question number 5, and we will talk about this quite a bit in class come the beginning of August. This will be one of the first things we talk about. So on number 5, we're looking at the leading causes of death, ages 10 to 14 and ages 15 to 19. And you have the different percentages here for different types of death. All right, well, A, it says the mode for each age group is unintentional injuries. Are mean and median useful ways to look at this data? No, because our data is what we're going to call categorical. That means that each subject is split into a certain category. Each subject doesn't have a test score that you can average together. You know, there's not an average cause of death. That doesn't make sense. If you were looking at test scores for all ages 10 to 14 on a certain test, then there is an average test score. You can add up all of those and divide. You can pick the number in the middle. So you can do one of those two measures of central tendency. That's what that's called, mean and median. Okay? Or center measure is what we'll kind of talk about it really as. But you cannot take the average cause of death. I mean, I guess it would be homicide or suicide in the middle, or suicide and cancer if you move over to the right. But since it is categorical, everybody is split into a category, not assigned a number. So the data is categorical, not quantitative. That means that little Jimmy Joe Bob, who passed away at age 13, is not assigned a death number. He is assigned a death cause, which is not a number. It can't be averaged with all the other deaths. Okay, it falls into a percentage. That's a really big difference that we'll talk about a lot, again, coming the first few weeks of school. It's one of the first things we talk about. Okay? And part B, and what other types of real-world data is mode the most useful? I mean, you can be creative here. There's a lot of different things in the real world where mode is more useful, aka anything that's set into a category. It could be favorite restaurant. If you're asking a bunch of teenagers, what's your favorite restaurant? Then the most likely to occur is going to be the most favorite restaurant. So that would be a instance where mode, being the most likely to occur answer, is good, is useful there. Okay, again, that's because it's categorical. You're asking a categorical question. You're not asking someone to rate McDonald's on a scale of 1 to 10. You're asking, what is your favorite restaurant? Their answer is not a number that can be averaged with other numbers. It is a category they're falling into. I'm falling into the Chick-fil-A category, or the Taco Bell category, or the Krystals category. Did anybody do Krystals all you can eat this summer? If not, you should. There's still time. It's pretty delicious. I only ate 8 of them, so I'm kind of disappointed in my outcome there. But anyways, it was pretty tasty. I plan on going back at least once. I mean, I'm going for 16, but I'm probably going to regret that all day later. Anyways, this is not a plug for Krystals, by the way. It's just a random note there. All right, part C. While the 6 leading causes of death are the same in both age groups, there are some marked differences. Name 3 differences and provide some possible educated guesses as to why these may exist. Obviously, homicide is more prevalent in the older kids. You know, you could say that kids get, 15 to 19, they might get involved in gangs and drugs, which oftentimes lead to homicide. So that could be one difference. Another difference is that congenital effects are more likely in the younger kids, probably because it's harder to survive past age 14 with types of congenital effects. Also the same with cancer. Generally cancers are detected, childhood cancers are detected earlier. So if if a patient is not going to survive, it's probably going to happen in those ages 10 to 14 rather than 15 to 19. Okay? Heart disease, more prevalent in 10 to 14. Again, if they're able to survive through 10 to 14, then their disease is probably not severe enough that is going to have them die at age 15 to 19. So again, just common sense, logical answers there. Nothing fancy, nothing mathematical. Just look at analyzing data and seeing when things are useful. And the last thing we're going to do is look at the number 6, just real quick, creating a dot plot and use it to calculate the mean, median, and mode of the rounded data. Okay, well, a dot plot, here's going to be our x-axis. We don't really have a y-axis. And let's see, the lowest is probably Montreal. No, Florida is actually lower. So we'll start at 10,000. I'm going to go 12,000. I'm just going to go up by, I should have went up by more. As we go all the way up, 40,000. San Francisco, they love their baseball. All right, and what you're going to do basically is you're going to put a dot for each team after you round things up, and then you can see what the data looks like. So Anaheim, 27,299. We're rounding up to the nearest 500, so that's going to be 27,250 is going to be over here somewhere. Arizona, 40,000, way down here. Atlanta, 33,000, going to be in between those two. I'm doing a very rough sketch. I would expect y'all maybe to number them by 5s instead of 2s like I did, and try to make it a little bit more exact here. Baltimore is right there with Atlanta. Boston is also right there with Atlanta, just a little bit less maybe. Okay, and you can kind of see you'll have a dot for each of the major league teams, and you can see the mean. You could add them up and divide by 31, 32. I can't remember how many major league teams there are. You could, for the median, you could find the one in the middle. You could order them least to greatest and do that. Okay, mode is going to be the tallest dot plot stack. Okay, it looks like the 33,000 right now with my little small set of data. Okay, and then the range you would take, did I say San Francisco? No, New York Yankees. Holy cow, 45,000. And you would subtract Florida, which is now the Miami Marlins, and you would subtract those to get your range. Okay, so that's kind of how you proceed with number 6. Anyway, so that is the first activity. Do the best you can. If you have any more questions on this, please comment below under the video, and I will help you guys out on that. And I have updates available, always updates available. And until next time, which will probably be in a few minutes, I'm trying to get 3 or 4 of these done while the kids are napping. Adios.